Today we are going to do some introductions with science inquiry. We're going to learn about how real scientists do real science in the world. Okay? On the 22nd of this month, you will have the opportunity to go to Red Butte Gardens, where you will have the day to be a field scientist, where you will be given pictures of plants that you have to go and identify them by their characteristics that you find in the picture and those type of things. So you will have the opportunity to be the field scientist, or what field scientists do in our world today. To think like scientists, to do scientific inquiry, to ask some of those questions, okay? What we're going to do first is look at our objectives and the purpose of what we're doing. This is your final 4th term project for science. So you're going to demonstrate all the stuff we've learned this year and how well you've learned that. So first, I would like you each to read with me the objectives that we've got set up for today. And you have a copy of this on your desk. Read with me on the count of 3. 1, 2, 3.
I can record observations of patterns found in growing a mystery seed to determine the type of plant.
Very good. What do you think that means? What do you think that looks like, Rebecca? Do you have any idea what that might look like? To record observations.
To write what you see.
To write what you see, good. Okay, anybody else have any other ideas of what we might see in recording observations of patterns? Jordan?
Like you search the plants or...
Okay, research the plants possibly, okay. Okay,
Look at all the different patterns in flowers.
looking at the patterns of the flowers, very good. Okay, anything else, Jeff?
Being able to identify the plant.
Being able to identify the plant. That is your end goal, okay? You will be given a mystery seed. You will not know what the seed is. Now, on some of the examples that I've brought for you today, scientists have already done this work, okay? When you go to the store and you buy a plant, they commonly come with one of these. The back of this has instructions. How to take care of it, how much moisture it needs, what it needs to live, what it needs to survive. Okay, a scientist did that a long time ago. They learned what these plants need to survive. Some of them need more sun, some of them need less sun, right? So, and they gave us these instructions. When you complete your project, you are the scientist, and you are given no instructions. Yes, I have your instructions on the back of your seed packet, but you get only the seed and the number of the seed. So you're not going to have instructions on how to take care of it. This seed that you found will be a mystery seed, okay? And then you're going to look for these, you're going to make observations for the patterns found in your seed. What are their leaf shapes? What are their characteristics? And given the opportunity to research that to see if you can determine what your seed is. Yes, ma'am?
All the plants that we will be growing, are they all going to be flowers?
I will tell you, the seeds that you are growing, they will flower, but the flower will turn into something else. You are not growing a tree.
Fruit and vegetables?
You are growing something that will eventually be edible. But I will not tell you what edible plant you are growing. Okay?
Will we be able to take them home to eat them?
You may take them home and grow them in your backyard if you'd like once we're done with the project. Yes.
Are we all having the same kind of seed?
No, you will not all have the same type of seed. I actually have 28 different types of seeds in my box of mystery seeds right here. So there's a good possibility that somebody in the class might have the same seed number as you. Somebody in the class may not have the same seed number as you. Okay? So you may be able to compare your results to a classmate, and then again, you may not. Okay? So it's going to be very, very important that you be good scientists, that you keep good data. Okay? Let's read our next objective. On the count of 3, 1, 2, 3.
I can record data correctly to show and find patterns within a certain plant type.
Okay? One thing you have to understand, what is all data recorded in? Do I record it in inches? Do I record it in standard measurement? Do I record it in metric? In scientists, if we're scientists, what do I have to record in? What is my international unit of measure, Cheyenne?
That's the last what you said. Next.
Metric, correct. So all of your measurements, when you start measuring growth patterns, and you start collecting your data, and you go from day 1 to the day you plant it, to the day of germination, okay? All of those patterns have to be recorded in metric, okay? What are some metric standard units of measure? What are they?
Like meter,
Meter. What's another one, Jimmy?
centimeter,
Centimeter, okay.
milliliter.
Liter, good. Jackson? You forgot? Okay, we can come back to you. Garrett?
Kilometer.
Kilometer. Okay, there's one other standard unit of measure that we haven't talked about. We've got liter and we've got meter.
Decimeter.
No. Starts with a G. We learned about it earlier.
Gram.
Gram. Okay, those are our standard units of measures. Now we always have kilogram, millimeter, those type of things. The kilo, milli, and centa, deci, and deca, they move within each system, correct? I suggest that you use centimeters for your growth, okay? We all have rulers back there that you can measure growth with. I suggest you use centimeters. And our last objective for this will be, read this with me, on the count of 3, 1, 2, 3.
I can communicate my findings through oral and written communication to determine the scientific outcome of an experiment.
Okay, so this is, you each have been given a notebook. This is your plant journal. If you would like to open up to the first page, and you can write my plant journal and your name here, then on the next page you may write notes. So today as we talk about what you're going to be doing and what is expected, you may take notes on what your expectation is for this project. Give you just a few moments to finish that up. So my plant journal and your name. All right, can I get a thumbs up for everybody who has that first page ready? Okay, a thumbs up. No, thumbs up. And look, thank you. Thumbs up. Okay, perfect. All right, now, the state standards that you will be covering in this, the state asks me as a teacher to teach you these standards. The first one is students will be able to use scientific processes and thinking skills by completing the following tasks. So this is what your expected outcome is. We've got our objectives, what you should be able to do. This is how it ties into what you should be learning. Okay, you need to observe simple objects, patterns, and events and report their observations. Students should be able to sort and sequence data according to a criteria given. So we're going to sort our data of growth by days. Okay, so we're going to start with day 1, day 2, day 3. No growth, no growth. And maybe on day 3 you see some growth. And day 4 it's grown some more. And you're going to measure your plant every day. And we're going to record that growth pattern and how quickly your plant grows by measuring it from the base of the plant to the top of the stem. Okay? Then compare things and processes and events. So you're going to compare your plant growth with somebody else's growth. Somebody else's plant may germinate faster than your plant. Okay? Germinate meaning it's starting to grow. And I've got some key terms for you that you will be writing down on your packet in just a moment. Okay, students will communicate effectively using science, language, and reasoning. You need to record your data accurately when given the appropriate form. Use scientific language in oral and written communication, and describe or explain observations carefully and report them with pictures, sentences, and models. So that means when you get ready to communicate your final results for your report, you're going to draw me pictures. You're going to put it in words. you may put a model together. Jasmine?
Will we have one of those flowers up there?
It will not be one of these flowers up here, no. These flowers we're going to use to see what type of characteristics we can find in these plants. Can the characteristics of these plants help us determine the type of plant? We're going to do that in just a moment before we get started. Okay, key terms. Germination. So if you want to write down your key terms in your packet, germination is the time it takes for a seed to mature into growth or to open up and start sprouting a plant. So time it takes a seed to mature to grow a plant, okay? That is what we call the germination process. So when you put your seed inside your soil today, it may take 5 days for it to grow. It may take 10 days for it to grow. We may have growth in 3 days, okay? Depending on type of seed, every seed grows different. Jeff?
Possibly could we have growth in 1 day?
1 day would be a little fast, so I don't know that you'll have growth in 1 day. They need a little bit longer than that. Okay, growth pattern is how quickly it grows. All right, now we're looking at characteristics. For you to determine how your plant will grow or will not grow, you are going to be looking at characteristics of a plant, okay? Because you have to decide what, David, will you take that there? And then you guys can pass these around. I want you to take just a few minutes and pass them around while I'm talking to you to determine some characteristics and write those characteristics down on your sheet that you have here. What are characteristics? What can we think about as a characteristic? What would they be? Jordan, give me an idea.
Something passed down or something.
Okay, passed down, but a little more detail. Jeff?
Maybe it's color?
Okay, color. Leaf color is a characteristic. Okay, does it have a stem? Does it not have a stem? What are some other things that we could look at? Ethan?
Size.
Size, how big is it grow?
The petals.
The petals, the shape of the petals, good. Okay, Jasmine?
How many petals?
How many petals it has, okay, good.
The inside of this one. I don't know what it's called.
Okay. Garrett?
Like the height of the plant.
The height of the plant, okay. The size of the leaves, these are all characteristics that will help you determine your plant, okay. These are all characteristics that will help you be able to search out what your seed is. So these will be important things to record in your observations as you do your experiment, correct? Okay. Now, what you will be doing and what your objectives are, and we're going to go ahead and look at this. Your mission is, 1, you're going to set up your journal as you have this here, and everybody will get the opportunity to sit down and do this after I get through explaining it. So if I can just get everybody to listen, that would be great. Page 1, you're going to write your instructions. That's what you have been given today as far as your instructions on how to do this. Okay, page 2, you're going to record any questions you might have about your plant growth. What I wonder if this will happen. I wonder if that will happen, so that when you get ready to write your research information, you can go back and look and see if your research answered any of your questions. Okay? Then you will be looking at this inquiry question. This is the question that we will be answering with this project. Using collected data, observations, and identifying patterns, is it possible to determine the type of plant developed from an unknown seed? Excuse me. That is the question that you will be answering, okay? Excuse me. Procedure. You will need to develop a step-by-step procedure for how you planted your seed and the steps you took. If you need additional space, you can change the number of your pages as needed. Okay, so you don't need to follow this, your page numbers just need to be consecutive. Okay? Then pages 5 through 8, that's going to be where you're going to record all your observations of your seeds, all of your growth. We have a plant light set up in the back of the classroom. How long the light will be left on, we will record that on the board every day, what time the light gets turned on, what time the light gets turned off. That plant light simulates for the plants what it's like to be outside in 12 hours of sunlight, or how many hours of sunlight we may have that day according to sunrise and sunset, okay? Then you're going to graph your growth pattern of the plant by each day once you get this. So you've got to create a data table to start doing that. Day 1, no growth. Day 2, no growth. Day 3, I had a growth and it was 1 centimeter. Day 4, I had growth and it was 5 centimeters. So that you can graph that growth pattern so we can see how rapidly your plant's growing. Then page 11, you're going to research your inquiry question using observations you've gathered to determine the type of plant by its characteristics and record your research findings. So you're going to write down what you find from looking at the internet, okay? Then, page 13 to 14, you will be doing your conclusion. This is where you're going to write 2 to 3 paragraphs of your conclusion for the information that you found out from growing your seed. To round back to, can you answer our inquiry question? Can you now tell me that yes, it's possible to look at the characteristics of the plant, observe the growing patterns of a plant, to determine the type of plant that it is, okay? Then, today, you're going to gather your supplies and plant your plant according to your procedures. Refer back to your demonstration. So I'm going to demonstrate for you exactly how you're going to do that. Then step 3, you're going to gather your data and observations on a daily basis for the next 14 days. Step 4, you're going to complete your scientific journal research and data and conclusion, and your book is due back to me on May 20th. Okay? On May 20th is when that is due. So what you will do is you're going to come up to me. You will get a cup. Before you plant in your cup, you want to poke some drainage holes. Because if none of your seeds are swamp seeds, guys. So if you overwater your plant and you don't have a drainage point for that extra water to come out, your poor little seed is going to drown. It's never going to grow. It's just going to drown. Because none of these seeds will grow in a swamp. Okay? That I have for you today. So you want to poke the holes. You then will get your seed pod. Now this is a soil pod. This is a dehydrated soil pod that I put water in. When I put water in, it then looks like this. You will get your seed, and you can see that there's a hole in the top of this soil pod. And you will put it inside your cup. You will then take your seed and push your seed inside with the soil pod, okay? I would suggest that you use the top end of your pencil or a pen to push that seed down gently inside your soil pod, okay? You do not need to push it hard, because if you push it hard, you might break your seed in half, and if you break your seed in half, it won't grow. Then, you will come up and get some potting soil and put over the top of your seed, okay? Some things that you need to do once you get your seed and your supplies, you need to record your seed number. Before you plant your seed, what is a good thing that you think you should do in your observations before you plant that seed? Cheyenne?
See how the seed looks?
See how the seed looks. Write that seed down. Maybe take a measurement of the seed, okay? Look at the seed, and is it a long seed? Some of these seeds might be a centimeter long. Some of them might be really teeny and not even a millimeter long, okay? Those are all things that you can use to gather scientific data to determine what your plant is. Do I have any questions from anybody before we get started on planting and designing our procedures? Lexi?
I think we should draw a picture of our seed.
Draw a picture of your seed. That would be very good. Jordan?
I have a question.
Yes.
Are you doing it like right now, or
We are going to do it right now. I'm going to ask you to write down your procedures step by step as you do them, okay? So as you do your procedures, I want you to write them down step by step. Now, normally, would a scientist ever do his procedures and this at the same time? No. Why? He has his procedures drawn up. But in the process of wanting to teach you how procedures should be done, I want you to write your procedures down step by step of everything you did. This needs to be detailed, okay? I should be able to take one of your books and go give it to the 6th grade teacher and one of her students, and one of their students should be able to recreate your experiment just by following your procedures and never talking to you. So that's how detailed they need to be. Okay, Jasmine?
What is inquiry?
Inquiry is the overall form of science, okay? So humans are naturally curious, right? We wonder about a lot of things. So we used to say experiment, but there's really 3 different types of science inquiry that we can do. We can do observation, we can categorize something, or we can do something in an experiment. So inquiry is the big umbrella of science. It's how we learn about things that we wonder about. We go out and we inquire. We ask questions, we learn, we observe. So science inquiry is that big word of how we learn science. Okay? Nevaeh?
Okay, so for our pages, like 15 to 18, like when we have those steps, are we going to write that down on a piece of paper?
You're going to write everything down in your journal. So everything should be recorded in your journal. Okay, yes, Addie?
Would you write it in your notes?
I would write it in my notes and my journal in whatever section that it goes in. So if it's an observation, where would it go? In your observation section. If you're tracking how much it's grown, where would that go? If you're measuring it, where would it go? Growth pattern, or what do I call that? Go ahead. Are you You forgot? Okay. You're going to move past, it's your data. So whenever you make measurements, that's your data. Observations are part of your data, but when you get specific numbers, that's when you're going to write down in your data section. Okay?
How many pages will our observation?
As many as you need to do a good job. So you may want to observe your plant every day and write down things that you notice. Some of my students who have done this in the past never grew a plant, but they grew a mushroom. They never grew a plant, but they grew a mushroom. There was something happening in their cup. They gave it too much moisture. It didn't get enough sunlight. Mushrooms grow in cool, dark places without a seed. They have a seed there, but they do grow to a cool, dark place. Okay? So what you will do is you're going to get your soil plant, like I have here, and then I will give you a mystery seed. And I'm going to do mystery seed number 1. Nope, that one's empty. I'm not going to do mystery seed number 1. Okay. I am going to do mystery seed number 3. Okay. So I'm going to pull this seed out. Before I do that, I'm going to look at my seed. This is a really large seed. Okay. Some of your seeds will be small. I might make those observations in my book, record it. I will then take my seed, push it just down inside that soil pod, squish my soil pod together so it's covered, and then I'm going to put some dirt on it to cover up the soil pod. And I don't have this open yet, so I will do that in just a moment. But cover it up. I will then take it back. Once I'm done with making my observations and writing my procedures down today, take it back and put it underneath the growing lights. Do we have any questions before I get started? Yes, ma'am.
Will we write our name on the cup?
Yes, you should identify your cup so that you know it's yours. Yes, Jasmine?
Will we write the seed number on the cup too?
I would. A lot of students do to keep track of it. Okay? All right. On the count of 3, I'm going to have you get in, I'll call you up row by row to get your soil pod, your cup, and I'll give you a seed. So let's start with Annabelle. Row. Okay, there's a cup. There's a soil pod, okay. Oh, turn your cup over. And you're getting seed number 19, ma'am. Okay, if you will take 2 of those little seeds. Okay, go ahead. Okay, grab a cup. And I'm going to give you that one. Seed number 20. All right, now that everybody has completed their project today, and ideally you have recorded what your seed looks like, what the size is, what your procedures were, how you put that together, we will be placing our plants over underneath, our seeds over underneath the seed light, the plant growing light, to go ahead and record what happens with them for the next 14 days. We'll be recording our observations. I hope you guys enjoyed this lesson. We all should have a lot of fun looking at the growth of our seeds.
Could you please introduce yourself today?
I'm Jasmine Haynes.
I am Jimmy Barrett. My name is Garrett Walters.
What do you think of Mrs. Pandoff as your science teacher?
She's a great science teacher.
Okay, so what is it that makes her great? What do you like about her science classes?
I like the hands-on experiment stuff.
Well, we get to do hands-on experience where we get to, like, we had chickens and we got to hold them, and then we had caterpillars.
I think when we did our hot air balloons that we were making earlier, there was like a lot of problem solving because we had to make sure we built it right and filled the right hot air so it would fly. So yeah.
Okay. Do you know what inquiry-based science is?
No.
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 No. Okay. Well, I understand that you are going off to a science lab with Mrs. Pandoff. Is that correct?
Yeah.
Okay. Now, after she gets done with that lab, do you mind if I bring you back in here and ask you again what inquiry science is?
Sure.
So, Garrett, yesterday I asked you if you knew what inquiry-based science was, and you didn't. Could you explain today what is inquiry-based science?
Yeah. Inquiry-based science means it's like a hands-on activity where you get to discover what happens. Like you get to do you have no instructions and you just get to see what happens and you try your own ideas.
Okay, well, does that hurt your education if it doesn't work?
No, because it means that you're actually learning things, because if you do something and doesn't work or something really cool or bad happens, then you know either to do it or to not to do it again.
Okay. Now, how has this inquiry-based science been different from some of the science classes you've had before?
Well, it's been different because Mrs. Pandoff, she most of the time when we do science, it's she lets us do inquiry-based and not cookbook science, because she just wants us to see what happens by ourselves, what we can do.
Okay. And could you explain what cookbook science means to you?
Cookbook science is when the teacher tells you what to do and what it's going to be.
Okay. And what did you think of yesterday's experiment?
Yesterday's experiment was pretty cool how she led us. She didn't tell us anything what to do. She said that put the seeds in the cup and that's it. She didn't tell us to do anything else. So we kind of have to figure it out on our own.